to the drupa Touchpoint Sustainability stage. I'm Shirin De Bruyn, your moderator for the whole time. And I'm very happy to announce our next presentation. Our next speaker is Benedikt Fiedler, product manager at EyeC. EyeC is a leading developer of print inspection systems dedicated to improving efficiency and promoting sustainable resources. In this presentation, entitled Efficient and Sustainable Use of Resources with the Help of Print Quality Inspection and Artificial Intelligence, our speaker will discuss how EyeC is revolutionizing exactly that. Print quality inspection through the use of AI. He will explore how AI can improve equipment efficiency, optimize resource use, and reduce waste by identifying critical print defects, assisting in quality assurance, and detecting machine problems early. Mr. Fiedler joined EyeC in 2015 as a service technician, gaining extensive hands-on experience and understanding customer challenges. And since 2018, he has been a product manager responsible for overseeing print inspection systems for Sheetfed presses. So here he brings a lot of experience to the table. And please welcome Benedikt Fiedler.
Hello, and thank you for attending my presentation. Not much to add. I'm going to talk about the efficient and sustainable use of resources with the help of print quality inspection and artificial intelligence. Quite a mouthful, but becoming a more and more interesting topic. So I'm going to jump over those two slides thanks to the awesome introduction. So we, as a provider for print inspection systems, are developing systems for the whole process of print, starting in pre-press, going all the way down to incoming control of the print buyer. And we see all the challenges print shops are challenged with today. Those are quite extensive, mainly based on profitability, productivity, and sustainability, but accompanied by efficient material use, product quality, equipment efficiency, qualified personnel, material availability, sustainable resources, and so on. So quite a lot of points to tackle in the world today. So conventionally, customers approach us mostly to check the correctness and the completeness of the print image, content and elements in compliance with norms like Braille and barcodes, codes in general, preventing mix-ups for pharmaceutical companies, very important, cleanliness of materials and products, and in general ensuring the quality on a defined level, independent of personnel and time of production. Going more into detail with inline inspection systems, we can do real-time detections of deviations and create an immediate response as soon as a deviation or something going wrong is detected. We can do visual representation to the machine operator. We can issue machine reactions like a stop, an alarm, or even mark or sort a defect, making sure there's error-free delivery to the end customer. But of course, depending on where you inspect in your print process, also reducing waste material in case of a real print problem. The thing that we have with conventional print inspection systems is we only have limited categorization capabilities. So in the past, it was only possible to define defects or classify defects by geometrical features, by checking if it's a long defect, is it a round defect, and thereby guessing, is it a spot, is it a material impurity, is it a scratch on the printing plate, but that was it. We only could say it's a round defect or it's a long defect. We could also do statistic evaluation. How often does it occur? Is it on every page? I have a problem with my plates. Is it something that's only happening randomly? I guess it's mostly material impurity, but also spots and splashes. They're randomly also, but the criticality is not always the same. Of course, we could also go by position. Yeah? A position on the edge that is cut away, not that important as something that is within the print image. A homogeneous area might be less of a priority as an area where I have a picture, a face, or a company logo. But in general, we always have a very rough estimation on what the criticality of a defect or deviation is. So the problem we always have, we always need still experienced personnel to identify the source of the problem, evaluate the criticality still, correct the deviation, and if necessary, take action to prevent the deviation from happening again. So because of this involvement of the personnel, it was only really viable for customers with expensive, high quality materials. Yeah, reducing waste, saving the materials, saving cost was the focus. Yeah, or for premium print buyers that were able that are able or want specifically to pay for this quality level and would pay for the waste that is produced by sorting out, even if it's unsure if it's a material impurity or a real defect. So it was not really feasible for cheaper or recycled materials due to fibers or other material impurities that could create false positives, and therefore not really interesting for cost-sensitive print buyers or like an FMCG or commercial printing. So we always had the challenge in the past, finding the sweet spot for the maximum sensitivity of the inspection system by finding the defects that are important and ignoring the deviations that are acceptable, like material deviations. So with conventional print inspection, we are able to attack at least some of the points or challenges a print shop owner or manager is facing. So the focus was mainly on product quality, equipment efficiency to somewhat of a degree, and mostly waste reduction. So not a lot of the challenges a print shop manager or owner is facing. So there are additional challenges coming in today in the past, in the short-term past. Mainly sustainable and recycling materials are becoming chic. You can use it to create an image for your product, make your product appear more sustainable, you know, as a design element, but also as a requirement because of regulations. So the necessity to identify print problems without detecting the material impurities become more and more and higher priority. Because of that, we invested a lot of time, and this drupa we are introducing print inspection with AI classification. So this allows us to do a content-based analysis of every detected deviation and do an objective evaluation of the deviation and autonomously identify the source even. So with that, we can reduce false alarms and reduce the detection of acceptable deviations, avoiding unnecessary machine stops, unnecessary sorting out of defects where the system was unsure if it's a spot or a material defect. And in general, it allows the inspection of materials with impurities while increasing the overall sensitivity of the inspection. So in total, we are mainly maximizing the focus of the machine operator on the real issues. He is not occupied anymore by evaluating the detected deviations, if they are material impurities, something acceptable, or a real spot, a real splash, or something he can do against on his machine. So with this, we are able to get a little bit more of the challenges tackled. We can now can reduce the requirements for the personnel. We can shift the experience towards the inspection system. We can share experience from different customers, put the intelligence into our inspection system, and make the user of the inspection system profit from that shared experience. We can reduce faults. We can of course, do a better waste reduction. We can create higher product quality. We're not depending on the product quality itself anymore. We have more material availability because we can choose from more materials. We're not constrained to the high quality materials anymore. And for that, we also can use more sustainable resources like recycled materials, recycled cartons. But that's not really where we ended. So in the concept phase of all this, we discovered that there are way more possibilities. While talking with the customers, the first goal was always to differentiate between a spot and a material defect. But during our learning phase, we discovered so much more. Yeah? We are not just differentiating anymore between a spot and a material defect. We could identify insects, wrinkles, ink spot, washing fluids, different kinds of spots of washing fluids, different kinds of spots of greases. We have ink droplets, splashes, stains, dirt, scumming, misregistration, doubling, and everything has a very specific source. And by that, we can, when we identify a specific class of a deviation, we can go back and tell exactly the operator what he can do to possibly stop this from happening again, at least for the press run or whatever. So in total, we create a completely new way of using print inspection. We're not only checking for defects anymore, but we become a tool for recommendations for the operator. So we're working very close with our partners like Koenig & Bauer, Manroland, and Landa, and Sheetfed for specifically, to develop tools to help our customers combine the data the print inspection systems create with different sources of other information, like sensors on the press, observe key and performance indices, identify issues as early as possible, like, for instance, a spot appearing always in the same area, but very sporadically, let's say every other job, but not in every job. By that, creating plans for preventive actions and give guidance for the operator to optimize the overall machine productivity and not only efficiency. So just a few examples what already happened, even though we're only in a passive mode. With the inspection system, we can now monitor paper quality over a long period of time. We can identify the trend of impurities, accumulation of impurities, and for instance, you can go back to your supplier, talk to him, your material is getting worse and worse, we need to talk. We can evaluate consumables. A real example is one of our customers that is working with us in this is changed washing fluids for his KBA press. And suddenly we had a lot of spots appearing out of nowhere, but only sporadically, and we identified this as the change of the washing fluid, which had a slightly different viscosity and creating spots at higher speed. So the performance of the new washing fluid was worse, even though it was cheaper than the old one. So the customer reverted to the old one. And that basically comes back to optimizing machine parameters, optimizing substrate and consumable usages, adjust print-related settings, and therefore identifying measures. Also, we're not only constrained to materials, but we can also trigger certain washing programs of a machine automatically, depending on what defects we detect. And we can also do recommendation for the machine operator to change certain things, like identifying grease problems on a certain print unit. Of course, we can tell them, have a look and clean that specific print unit. So in total, we gain productivity monitoring instead of efficiency monitoring, and we can find the sweet spot between print quality, machine speed, and can create dynamic preventive maintenance plans, data-driven service plans that are based on not assumptions, but observing trends that we can see in the print image. So with that, the print inspection is not focused on quality of the print product anymore, but becomes a system that creates a holistic view of the print product, the print process, and can observe and evaluate the whole print process in total. So with that, we can almost tackle all challenges, or most of the challenges a print shop owner or floor manager is faced today. So the key learnings. With an AI-empowered print inspection, we can ensure print quality independently of material quality. We can significantly increase the efficient use of materials and press time, support the operator of the machine to identify the root causes of a defect, and therefore faster finding a solution. And we can create a big data by the print inspection that can be used to monitor key performance indices, analyze the real productivity of a press, and not only the overall equipment efficiency, and automate processes around the press, and automate decision making. So that is all. If you want to see it in the real, come to our booth and experience AI-empowered print inspection. Thank you.
Applause for Mr. Fiedler. Thank you very much. Wow, what an exciting journey you made with EyeC.
Yeah.
Wow. Are there any questions? No, not yet? Okay. So you're also a co-exhibitor here on the Touchpoint Sustainability. So of course you can visit the booth in Hall 3, right?
Yeah.
But also here. So if you would like to have a short preview, then of course you will be happy to accompany to your smaller exhibit here, and then continue walking to Hall 3. Wonderful. Thank you very much, Mr. Fiedler. Thank you, and have a fruitful more time here on drupa. That's your applause.